Video mana? Video lagi. Okay. Link పంపిస్తున్నాను షేర్ చేయండి. Okay. Studyable. Okay. Audible. I'm checking in YouTube. Please share the link with your students. YouTube. YouTube it have muted everything. Just YouTube link you can post the YouTube link also. So that they, and also tell them that they have to open simultaneously two applications. The message in WhatsApp. Post in Google Meet. Okay. Good afternoon, everybody. All of you try to open both YouTube and Google Meet. Okay. No problem.
you open simultaneously both the links. So if you have any doubts, and if you stuck at any equation, if you have any doubts, please come into the Google Meet and ask the sir. Okay. మీకు ఎక్కడ డౌట్ వచ్చినా సరే అక్కడ ఆగిపోయి గూగుల్ మీట్ యాప్ గూగుల్ మీట్ నోటిఫికేషన్స్కి వెళ్ళి గూగుల్ మీట్లోకి సైన్ ఇన్ అయ్యి సార్ని క్వశ్చన్స్ అడిగితే ఎక్కడ స్ట్రక్ అయిపోయారో అక్కడ నుంచి మళ్ళీ యూట్యూబ్లో కంటిన్యూ చేస్తారు. ఎందుకంటే టూ వే ఇంటరాక్షన్ లేదు కదా, లాంగ్ టైం జూమ్లో తీసుకోవడానికి లేదు, ఓన్లీ 40 minutes టైంలో మీరు జాయిన్ అవ్వడం సో ఇదంతా పాసిబుల్ కాదని చెప్పి నేను గూగుల్ మీట్ అట్ సేమ్ టైం యూట్యూబ్ సైమల్టేనియస్ యూట్యూబ్లో మీరు డౌట్స్ అడగడానికి లేదు కదమ్మా.
Okay, good afternoon, everybody. Can you hear me? YouTube. Okay. Just we'll have 5 minutes recap of the last two classes. Then we can continue. Okay, just 1 minute. I'll restart this. Okay, can you see me? Sorry. Can you hit the screen? We have seen the DFT Basically, is a mathematical prism which converts or which dissects the given signal into number of frequency components, like a prism, optical prism. And then we have seen the equation for DFT. So this is a simple, continuous one-dimensional DFT formula. From that, we have seen a one-dimensional discrete Fourier transform, and we have seen the properties. Before we go for the properties, I think you can have a recap of how to calculate the DFT to given function or a signal. Uh, if we have DFT as f of u for a single or one-dimensional function or signal f of x, then its DFT is capital F of u, and its magnitude is as root of real part square plus imaginary part square, and its phase is given by tan inverse imaginary part by real part. These are the two things you know, how to calculate the magnitude and phase from the given DFT. Same way you should know how to calculate the power spectrum. Power spectrum is simply the magnitude square of u whole square, or take the magnitude and square means real part square plus imaginary part square. Let's see an example. All of you can take the screenshot of this example. This is an example. There is there, there is a signal which is expressed as f of x equal to 2344. Its value is 2344. Four values are there for given instance of time. And you have to calculate the DFT by using the formula, which we already know. F of x into e power minus j 2 pi n by n, small n by capital N. So you have to substitute these values in that. Then you will get capital F of 0, F of 1, F of 2, F of 3. Four values. Because they are asking DFT without specifying capital N value, you can take capital N as n equal to 4. You have to calculate F of 0, F of 1, F of 2, F of 3. Four values you need to find out. So what's the formula? This is the formula. This is the formula. E power minus j 2 pi by capital N into u into x. Yes. Where u is 0, 1 up to so on capital N minus 1. In this example, you have to take capital N as 4. So you have to start u equal to 0, 1, 2, 3. Four values 0, 1, 2, 3. So by using this formula, you can calculate capital F of u, four values. So once you calculate these four values, your DFT is done. You represent the DFT in a matrix. Right now, it is a one-dimensional DFT, simply represent in a what do you say, a set, four values. So Okay, once you calculate the one dimensional DFT, you can calculate the magnitude also. Look at the values f of 0 equal to 13. It is a real number, so no need to worry. F of 1 is minus 2 plus j. So you can calculate the magnitude as root of 2 square plus 1 square, which is root 5. So f of 2 is 1. F of 3 is root 5. So we have four values, four magnitudes. The same way, angle also. How to calculate the angle? Tan inverse imaginary part by real part. We have imaginary part and we have real part. So by using this, you can calculate both magnitude spectra and phase spectra for a given image or given signal by using one DFT. Then come to the 2DFT part. So this is the formula for two-dimensional DFT. There you can see f of u comma v DFT formula and inverse DFT from which you will get the original image f of x comma. So here we have seen the properties. And before properties, yes, there is a magnitude. F of u comma v equal to root of r square plus I square. Same, phi is tan inverse I by v. Wherever we have formula for one dimension, that is applicable to two dimension. But only thing is, instead of one variable u, you will have two variables u comma v. That is the only difference. Just formulas are same. Now see the beauty. There is an image, a black, and in the center there is a white rectangle. For this image, if you take the DFT, the DFT can have two parts, magnitude and phase. The magnitude spectrum will be like this. These center white lines are there because of this white rectangle, and this dot is there for the dark image. And the phase will be like this. And you can see from typical images, the textbook will have these images, and therefore spectra, different DFT spectra we can do by MATLAB. Simple MATLAB functions will give you a spectrum. The corresponding image will have spectrum like this. And what is the importance of magnitude and phase? This is magnitude and this is phase. Both will combine and give the IDFT to get the original back image. So we need both magnitude and phase of the given image to get the IDFT of the given image. The same way, there is a particular image. For that, the magnitude spectrum will be like this. The phase will be like this. We must- This is separability property. I asked you one thing, right? You have to prove the complex conjugate property of DFT and also try to get me the proof for average property of the 2DFT. Have you done it? Anybody? If you Google Meet, respond to me. Have you done this simple assignment of doing uh, average property and conjugate property? And also, you can prove the periodicity property. Simply, it's periodicity property. I have forwarded this document through your madam, so you can check this document. Simply prove the property. Next. And also there is one more property, a translation. In translation property, particularly this translation in the spatial domain and translation in the frequency domain. Spatial domain, we have seen the proof, and I want you to go for the frequency. See, so I want to shift in spatial domain, f of x minus x naught, y minus x, y naught will give this much scaling factor. If it goes to the left side, I can shift my spectrum by u naught and v naught. In particularly, if I want u naught equal to v naught equal to n by 2, I want to shift my frequency spectrum by n by 2 value, then what I have to do? You can see the proof is like this. This material also is forward to you. You see the original image has to be multiplied with a quantity called minus 1 whole power x plus y. Then my image spectrum will be shifted by n by 2 comma n by 2. So that is the property of shifting in frequency. Right now I will show you one video, a simple video, so that it's a graphical. I will show a simple video, graphical illusion of frequency spectrum.
We have an x-axis and a y-axis. Let us also create an axis that represents the angle theta. We have an x-axis and a y-axis.
You see the screen?
Let us also create an axis that represents the angle theta. We have an x-axis and a y-axis. Let us also create an axis that represents the angle positive. We have an x-axis and a y-axis. Let us also create an axis that represents the angle theta.
Yes, not yet.
Theta.
Yes.
We have an x-axis and a y-axis. Let us also create an axis that represents the angle theta. The green line rotates by the angle theta. For each value of theta, the x-coordinate represents the cosine of theta, and the y-coordinate represents the sine of theta. The angle theta can range anywhere between negative infinity and positive infinity.
see the video? It's a graphical illusion of how
The
sine
angle
waves
theta can
and
range
frequency
anywhere
waves
between negative infinity and positive
illusion
infinity.
of. You see the video?
Two-dimensional pattern is what we refer to as a sine wave.
It's a graphical illusion of how sine waves and frequency waves.
We can change the sine wave's amplitude. Suppose we have these two sine waves together. Suppose we have two sine waves that are identical except for the fact that they have different amplitudes. If we add these two sine waves together, the result can be represented graphically as shown. Now, suppose that the two sine waves also have different phases. The sum of these two waveforms can be represented graphically like this. Of the exact same frequency, but the result can be represented graphically as shown. Now, suppose